The unit is momentum. So after the whole, or today I guess, you're going to define what momentum is and be able to calculate momentum given mass and velocity. In other words, solve P equals m times v problems. This will be like a breath of fresh air for you because they are incredibly simple. That number times that number. What does momentum mean to you? Not much, Carter? If I said, Carter, your life depends on you giving me a definition of momentum, what would you say? And you can't say not much because your life's depending on it. Figuratively in this sense. What is momentum? What does it mean to you? Pardon me? The speed you move at? Is momentum related to speed? Do things that move faster have greater momentum? I think I heard yes. How much speed is conserved? Okay. So like when something's going through the air, like how much it keeps of its speed, it doesn't slow down due to friction, is that what you're saying? Okay. What about big objects? Like let's talk about trains. How come it's a bad idea to get in front of a train? It doesn't slow down fast, you're right. Right? They blow that annoying horn like miles ahead, right? Because they can't slow down fast. Like a car doing, say, 30 clicks can slow down relatively quick, right? A kid runs out in the street, they can get stopped pretty quick, right? But a train, even if it's going like just really slow, it's giant. Like I wouldn't even want to guess what the mass of a train is. How long does it take a train to slow down? A long way. And to speed up too, right? You sometimes see the really long trains as they're going through, you see the tail end of the train, it's actually going through town pretty quick, isn't it? How come? Because the engine's like halfway to Gilbert Plains already, right? They're already out of town, they're speeding up. So, I'm hearing that momentum is related to speed and mass. Golly. Okay. Great stuff, Oz. I did my tablecloth trick today with a full coffee cup. And the grade 11s were, they figured for sure I was going to get that. But I did it. I should show you. You've seen a lot, haven't you?
First day. Oh yeah, it's not too bad.
For any students that are getting retakes of the last name, or anyone else that we might have missed, including teachers or staff, can you please make your way down to the multi? Thank you.
You know what? I'm going to go sit down and see if they'll take a new picture for my yearbook, because I don't want you guys seeing me in the yearbook the way I look like this. Because I look like this. So I'm going to run down and see if they'll do a retake for the yearbook. It's a really the guy who's there loves it. I would like you to read just 7.1. Just the left-hand side of that sheet. Can you do that for me? Okay. What's important? What's important about momentum? Inertia? Mass has velocity. Oh, mass times velocity. That's right. So when they say momentum, it's in bold, right? By momentum, we mean inertia in motion. So inertia is that, right? Objects in motion stay in motion. Objects at rest stay at rest, right?
Yeah.
This is for fun. I need to practice for the afternoon class anyway. You guys saw this, right?
Yeah.
Some of you might not if you were first semester last year.
Oh.
Objects at rest stay at rest. You give me anything you want, I can do it.
Can I give you a sticker? Can I give you like a towel?
Harder. Will,
Towel?
Towel.
even harder.
Oh, you said yank me up from underneath there.
Could I what?
No.
A person? Probably not. I think that would be, the frictional coefficient would be a bit much. I will do any vessel up to probably about a liter of water.
A liter.
Probably. Probably do a liter of water.
Water for you? Looks like a hero. It just goes all over.
Momentum is inertia in motion. Okay, so inertia at rest is like the can on the tablecloth trick, right? Nick or Joel, you listening here? Right? So momentum is inertia in motion. And it is defined to be mass times velocity. Momentum is defined as an object's mass times its velocity. Hannah, phone away. Mass times velocity. And since velocity is a vector, that makes momentum a vector. So it is in fact the fifth vector quantity. The others are displacement, velocity, acceleration, force, and now you have momentum. In fact, when I first introduced you to vectors back in grade 11, remember there was a question that said, which one of the following is also a vector? The answer was momentum. Okay? Mass times velocity. This is in the textbook on page 277 if you want to follow along there. Now, what is the letter for momentum? P. Why? Well, because M is used for mass, so then they just pick the next letter in the alphabet. N, well, that's for newtons. Well, O is kind of looks like a 0, so let's go with P. It makes some sense? That's not the reason. I actually spent far too long, because kids always ask me, why do they use P for momentum? I spent far too long one day researching it. It's something to do with Newton and some Latin word that he used, but it's kind of been lost in the mist of time. It's hard to find out why they use P for momentum. They just do. So I can't help you. But you might be wondering what the units are, right? Because the units for mass are going to be what? Kilograms. And the units for velocity is? Meters per second. So therefore, the units of momentum are going to be kilogram meters per second. Now, if only like newtons, Carter, what are you doing? Okay, later. Listen. When you have a newton, right? When you go F equals ma, that's going to be kilogram meters per second squared. It's almost the same, right? And that is 1 newton. 1 newton is 1 kilogram meter per second squared. So you'd think there would be some famous scientist, usually a dude, because there's not a lot of female scientists. They weren't really allowed to be scientists back then, unfortunately, right? Marie Curie would be the one of the few. You'd think there would be some famous scientist that they would give that naming rights to units for momentum, and the answer is no, there isn't. Unfortunately, you're going to have to write kilogram meters per second squared. Sorry, kilogram meters per second. There is no unit. If you want to call it, you go right ahead. I've always wanted a unit named after me. No. No, I'll accept Bennett's as a unit, just for fun. Just, you're probably not going to be able to use it anywhere else, that's all, right? Like, just be aware that that's not going to work for you anywhere else. Okay, so, Mr. Bennett, why don't you show us an example of how to calculate momentum? Great question. Here's the one from the book. If you want to write it down, you can. Okay, this is the actual picture from the book. I took a picture and punched it in there. Calculate the momentum of a 1 kilogram duck moving at 28 meters per second. The author of this book, below there, and of a sumo wrestler with a mass of 200 kilograms moving at 0.5 kilometers per hour as shown. So those are the two values. I'm just going to pause for a second. So how are we going to do this? Calculate the momentum of a 1 kilogram duck moving at 28 meters per second and of a sumo wrestler with a mass of 200 at 0.5 as shown. So it's P equals mv. Now, one of the big deals in this unit is the use of subscripts. So I'm going to introduce you to that now. We've seen subscripts before, like FAX and stuff like that, right? Like VH and stuff like that. They're going to get more complicated. Okay? Organization and keeping track of things is paramount, key, paramount means like super important. Okay? And it's more just about keeping your stuff organized, which is why I've been building you up to this point. This is the point where, okay? So we're going to write momentum duck, PD, is going to be equal to mass of duck times velocity of duck. It's just P equals mv, because I called them ducks.
Do you have to call them ducks?
I know what's coming down the road. You have to keep things separate. All I've done is write P equals mv. Let me do it this way then. It's the duck, duck, duck. I knew you were going to say that.
Okay.
All I did was put a D on the bottom half. It's okay.
1.
Okay, so what is the momentum of the duck? Well, it's going to be 1 times 28. Surely you can do this without a calculator.
Better make sure Jeff's in.
It's got to be kilograms and meters per second.
If I say bets.
28. I'm going to be in so much trouble for that.
Uno. Times 28.
28.
Okay, let's do the next one.
Okay. Okay, so now we got to do it for the sumo, but he's moving at kilometers per hour. So you're going to take 0.5, divide by 3.6, and yes, you're going to show me that. Huh? What is what? Minutes. You can ignore that. Kilogram meters per second. So I get 0.139. Is that what you got? 0.139. No, I've converted that to meters per second. I've taken the 0.5 kilometers per hour, divided by 3.6, and got 0.139 meters per second. Now, 0.5, right here, right? Momentum equals mass times velocity, but the subscripts are going to be S's. And the subscripts are really up to you. I mean, if you want to call him a wrestler, go ahead. So the mass of the wrestler is going to be 200 times the speed is 0.139. And I've already got it in my calculator, so I'm just going to take that number and go times 200. And you will notice that they are virtually identical. So if I asked you, would you rather get hit by a 1 kilogram duck moving at 28 meters per second, or a sumo wrestler, 200 kilogram sumo wrestler moving at 0.5 kilometers an hour, it would be a coin toss, because it would be exactly the same impact.
No, it would be the same.
Exactly the same. Let's take it out and let's try it, Hannah. Let's, yeah?
Next one.
Okay, let's try it. Okay. So, for practice, now I realize that probably very few of you have your textbook here. Yes, I realize that. So maybe what I'm going to do is, maybe I'm going to run down to the photocopier and I'm just going to copy that page. Okay? While I...
We watch the video. Oh, shots fired.